Hi dear students, in this video we will discuss one of the problems of JEE Advanced 2023. As you know, there were three debatable problems from physics in 2023 and one of the questions was the very famous chimney problem. And the chimney problem finally IIT has dropped that question. And second one is a problem from wave optics. And we have discussed that problem in detail with the help of various animations. And the third one is this particular question. Actually, in this question, what is unveiling the hidden trio? I will explain the trio, solving the tricky physics question with detailed animations. See, it's a question, it's an integer answer type question, integer answer type. Okay, what is the peculiarity of such questions? See this. Yes, it's from section 3. This section contains six questions. The answer to each question is a non-negative integer. It's a non-negative integer. A single non-negative integer should be the answer. Okay, and rest of the thing full marks is 4 only if the correct integer is answered, and the 0 marks 0 in all other cases. That means no negative answers are there. Okay, now let's see what's our question. Yeah, this is the question. An optical arrangement consists of two concave mirrors M1 and M2 and a convex lens L. As shown in figure, see, this is the convex lens and the M1 M2 two concave mirrors. Okay, with a common principal axis as shown in figure. The focal length of L is 10 centimeter. Yes, focal length of this lens is see, yeah, focal length of this lens is 10 centimeter, isn't it? Yeah, it's 10 centimeter. Then the radii of curvature of M1 and M2 are 20 centimeter M1 and 24 centimeter for M2. That means the focal length is here 10 centimeter and here the focal length is 12 centimeter r by 2. Okay. The distance between L and M2 is 20 centimeter. It is given in the question. Moreover, a point object S is placed at the midpoint between L and M2 on the axis. That means this source S is placed at the midpoint of this line. Okay, that means at a distance 10 centimeter either from lens or from M2. Okay, it's clear. And finally, when the distance between L and M1 is n by 7, this distance, they are talking about this distance, it is given as n by 7 centimeter and you are supposed to find the n, and also it is given, see, one of the images coincides with S. There may form various images, but one of the images coincides with the object itself. This is given in the question. Okay. Now let's do the problem. See, yeah, as you know, here the focal length is, I have told you, this is 10 centimeter the focal length, and here also the focal length is found to be 10 centimeter and here the focal length is 12 centimeter. Okay. Yes, see, in any combination of lenses or mirrors, you know, what's the principle? The image formed by the first element acts as the virtual object for the second one, and image formed by the second element acts as the virtual object for the third element, and so on. In an exactly similar fashion, you can also consider here, see, this is the source or this is the object over here, and the light rays from this object, yes, let me consider first incident on this M2 and it will be reflected back into the lens. Okay, therefore let me consider this distance. This distance, as you know, this is 10 centimeter because S is placed at the midpoint of this 20 centimeter. It is given in the question. Therefore, the object distance is 10 centimeter, the focal length is 12, and first of all, we need to find the image position, image of the M2, the image formed by M2 alone, Okay, and that image will act as the object for the lens L. Okay, that's a simple thing. This question is not a complicated question. Keep it in mind. This is not a difficult question actually. This is not a difficult question. Okay, see, therefore I can say it is mirror formula 1 by f is equal to 1 by v plus 1 by u, 1 by v plus 1 by u, or 1 by v equal to 1 by f minus 1 by u. That is f is that is concave mirror, focal length is negative, minus 1 by 12 minus, see, object distance, light moves from here to this side, and object distance should be measured from the pole, therefore it's negative, minus 1 by 10. That is equal to LCM, let me take it as 120, then minus 10 plus 12. That is equal to 2 by 1 to, okay, 1 by 60. Or you can say V equal to 60 centimeter. V is equal to 60 centimeter. That means the image formed at a distance 60 centimeter from the pole of the mirror. 60 centimeter from the pole of the mirror. That means image will be formed somewhere over here, and obviously this distance should be 60 centimeter. Image forms behind the mirror, okay, and that image, let me mark it as I dash. This I dash acts as the virtual object for the lens L. I dash acts as the virtual object for the lens L. Okay, now our second task is what is our second task? See, our second task is to find the image position of the lens. For that, let me make use of lens formula. 1 by f is equal to 1 by v minus 1 by u, or 1 by v equal to 1 by f plus 1 by u. That is equal to, for the lens, the focal, it's convex lens, therefore the focal length is positive, therefore 1 by 10. Then light rays are coming from this side, because see, here light moves like this, and it will bend like this. Okay, okay, here also light comes, and incident here the angle of incidence is 0 degree, that is incidence normally, and it will retrace the path, and by extending both will coincide at the point I dash. Okay, that means the light rays are coming from there. Okay, therefore the object distance is negative, minus 1 by how much? See, this is considered, I dash is considered as the object, therefore this is 20 centimeter and this is 60, therefore the object distance is 80 centimeter. And is negative because that distance is measured from the optic center of the lens. Okay, and while moving from here to there, you are moving against the incident ray and is taken as negative. Okay, now what is this? This is if you take 80 as LCM, then 8 minus 1, 7 divided by 80, or V equal to 80 divided by 7 centimeter. 80 divided by 7 centimeter. Okay, 80 divided by 7. Okay, that means let me consider like this. This will come over here. Suppose this will come over here, and here forms the second image I double dash. Now the thing is that it is given in the question that the image is formed at the object itself. In order to form the image at the object itself, what should happen? See, there are here is the problem actually. The ray should retrace its path. If this ray should retrace the path, then you can say this point must be the center of curvature. If the light ray passes through the center of curvature, obviously this angle should be 90 degree. This angle is 90 degree then. Okay. And if this angle is 90 degree, that means the angle of incidence is 0. Then what will happen? Let me change the color. Okay. Then what will happen? the ray will retrace, like this. The ray will retrace the path, and finally the image I is formed over here. The image I will be formed. Okay, in this scenario you can say this distance is 80 divided by 7. 80 divided by 7 centimeter, and the focal length is 10 centimeter, and this is nothing but the radius of curvature. This is the radius of curvature 2f, that is equal to 20 centimeter, and you are supposed to find this distance, which is given as n by 7 in the question. Therefore, this n by 7 is nothing but 80 divided by 7 plus what? 20 centimeter. 20. Okay, that is 80 plus 140 divided by 7, and that is equal to 220 divided by 7 centimeter. And comparing the LHS and RHS, you can find n is equal to 220 centimeter. Obviously 220 centimeter is one of the correct answers, and also let's go through the animation. See this, the light rays from here. Enjoy the animation. Now this point is C, incident angle of incidence 0. It retraces the path exactly. Yeah. Yes, image forms at the object itself, center of curvature, and this distance is 80 divided by 7. See, once again the same thing. Okay, yes, this one is case 1. This is case 1. This is case 1. Case 1. And here this distance is 20 centimeter, and therefore this total distance, this is 220 divided by 7 centimeter. Therefore 220 is one of the correct answers. Now this is not the one and only one case. See, there is another case. See this. Yeah, exactly similar to the earlier case, exactly similar. Okay, now see the difference. Yeah, see, suppose this 80 divided by 7, this distance is 80 divided by 7. If it passes through the focus, earlier it was center of curvature, and if it is the focus, what happens? See, light rays when pass through the focus, what will happen? After reflection, the light rays will move parallel to the principal axis. Yeah, yes, it moves parallel. Again, the focal length of this lens is 10 centimeter. Obviously this length is also 10 centimeter. It is also 10 centimeter. Once again, and finally the image forms at the object itself. See again, exactly similar to the earlier case, no difference there. And here, yeah, after refraction, the light rays, if pass through the focus, that is 80 by 7 centimeter is the distance of the focus from the optic center or the focal length. Yeah, this is the case. This is our case 2. This is case 2. In case 2, this distance is 10 centimeter focal length of the mirror, and this is 80 by 7. Therefore, the total distance, this one, that is given as n by 7 centimeter in the question. See, that n by 7 is equal to 80 divided by 7 plus 10 centimeter, plus 10. That is equal to 80 plus 70 divided by 7. That is 150 divided by 150. 150 divided by 7 centimeter, which implies n is equal to 150. N is equal to 150 is the second answer. Second answer. This is also found to be the correct. Actually, it was supposed to get only a single integer, either 150 or 220 or something else. But already we got two correct answers. One more chance is there. One more chance is there. Let's explore the third case. The third case. Yeah. Third case. See, 80/7 is the entire length. That means the light ray incidents at the pole of the mirror. Pole of the mirror. What will happen? At the pole, you know, principal axis is the normal. Therefore, the ray will be reflected with the same angle. With the same angle. Yeah. See, light rays after reflection, it incidents at the pole of the mirror, and the light is reflected along this direction, and exactly it is exactly symmetrical. Therefore, again the image forms at the object itself. The image forms at the object itself. See again. Yeah. And in this case, 80/7 is the entire separation between M1 and L. Yes. See, this is the third case. This is the third case. And in this case, see, n/7 is nothing but 80 divided by 7. Therefore, n is equal to 80 is the third answer. N is equal to 80 is the third answer. Okay. Finally, as you know, IIT has given all the three correct answers. 220, 150 and 80 are correct answers. If you write any of these three answers, you will get the correct. You will get the mark. Okay. Anyway, now we have discussed the question in detail. Now the hidden trio is revealed. The hidden trio is revealed. Okay, that's all about this particular question. We can see again with another problem. Thank you.